Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 5th lesson on a given Form 2 mathematics topic called equations of a straight line. So we are looking at our third example, which is a past Kcse question tested in 2017, paper 1 question number 17. It reads that a straight line L1 whose equation is 2y minus 3x minus 6 is equals to 0 and L2 whose equation is 3y plus x minus 20 is equals to 0 intersect at a point A. So part A of the question, we are required to find the coordinates of point A. So because A is the point of intersection, we are going to say that at the point A, the equations of line L1 and the line L2 are actually simultaneous. They are simultaneous. Therefore, it means that we can solve those two equations using either elimination or substitution method. Now, I want to use elimination method because it is easier to work with. The equation for L1 was given as 2y, then minus 3x, then is equals to, I'll take 6 towards the right hand side so that it becomes a positive 6. Then the second equation for L2 is given as 3y, then of course plus x is equals to, I'll take negative 20 towards the right hand side so that it becomes a positive 20. Now using elimination method, I want to eliminate y. So for me to achieve that, I'll multiply it with the coefficient of y in the second equation, which is 3. Then of course the second equation, I multiply it with the coefficient of y of the first equation, which was a positive 2. Now if I open brackets, I'm going to have 2y multiplied by 3. So this will give me a positive 6y. Then of course negative 3x times 3, I'll get negative 9x being equal to 6 multiplied by 3, I'll get positive 18. Now 2 multiply with the second equation, I'll have 3y times 2, which will still give me positive 6y. Then of course 2 multiplied by x, I'll get a positive 2x being equal to 20 multiplied by 2, I'll get positive 40. Then I'll subtract the two equations so that I can easily eliminate y. So I'll end up with 6y minus 6y, which will give me 0. Then here I'll have negative 9x, then of course minus, then positive 2x being equal to positive 18, then of course minus 40. Now when I take negative 9, so of course this will be negative 9x, negative multiplied by positive, I'll get negative 2x being equal to positive 18, then of course minus 40. So negative 9x minus 2x minus simply means you are going to add the two numbers, then the final answer takes the sign of the larger number. So I'll have negative 9 plus 2, I'm going to get 11. So this will be a negative 11x being equal to 18 minus 40, I'm going to get a negative 22. Then if I divide through by negative 11, I also divide through by negative 11. So I'll end up with 11 and 11 will cancel out. Therefore, the value of x will be equal to positive 2. Therefore, my x will actually be equal to positive 2. Then I'll also substitute the value of x in one of the equations so that I can solve for the other unknown, which is y. So I'll say substituting x is equals to 2 in the first equation, which is the equation of the line L1. I'll have the following. Remember, L1 had the equation of 2y, then of course minus 3x, then minus 6 is equals to 0. When I substitute where I have x, I'll substitute with a positive 2. So this will be 2y, then of course minus 3 into my x is a positive 2, then minus 6 is equals to 0. So this will give me 2y, negative 3 times 2, I'll get negative 6, minus 6 being equal to 0, which will give me 2y, minus 6, I'll get negative 12 being equal to 0. Therefore, 2y will be equivalent to, when I take 12 towards the right hand side, I'll have 0 plus 12, which is positive 12. Then I divide through by 2. I also divide through by 2, so that 2 and 2 can actually cancel out. Therefore, my value of y will be equal to 12 divided by 2, which will give me a positive 6. Remember, the question wanted us to find the coordinates for the point A. So because point A is the point of intersection, then we know that at the point of intersection, the two equations should be simultaneous. So we'll say that the point A will be represented by the coordinates of x, then of course, comma, y. Therefore, the point A is going to have the coordinates of, our value of x was actually positive 2. So A will be positive 2, comma, our value of y is a positive 6. Therefore, the coordinates of point A is actually 2, 6. Then we look at part B of the question, whereby we are being told to that a third line L3 is perpendicular to L2 at the point A. Find the equation of L3 in the form y is equals to mx plus c. So the key point, we are told that L3 is perpendicular to L1. And we know that for any two perpendicular lines, the product of their gradients should give us -1. So because we already have the equation for L2, we can use it to find its gradient. So the equation for L2, we were given L2 as 3y plus x minus 20 is equals to 0. So let me copy this particular equation. So L2 had the equation of 3y, then of course plus x, 3y plus x minus 20 was being equal to 0. So for me to find the gradient of this particular line, I need to convert it in the form y is equals mx plus c. For me to achieve that, I'll say that 3y, I'll take the other values towards the right hand side. So of course, when x crosses equal sign, it becomes a negative x. Then of course, if negative 20 crosses equal sign, it becomes a positive 20. Then I'll divide through by 3, divided by 3, divided by 3, so that 3 and 3 can easily cancel out. So I'm going to remain with the equation being y is equals to, so here the coefficient is actually 1. So I can rewrite it as -1 over 3x, then of course plus 20 out of 3. So if I compare it with y is equals to mx, then of course plus c, you can clearly see that the gradient, which will be m1, is actually equal to -1/3. So because we are told that the two lines are perpendicular to each other, and we know that for any given pair of perpendicular lines, the product of their gradients should be -1. Therefore, I'll say that the gradient of L3 or L2 multiplied by the gradient of L3 should give me -1. If I let the gradient of L3, L2 to be m1, it simply means that m1 multiplied by m2, which is the gradient of L3, it should give me -1. Therefore, because I already have m1, I'll simply substitute, so that I say if m1 is -1/3, I'll have -1/3 multiplied by m2. The answer should give me -1. Therefore, if I multiply through with the reciprocal of course is 3 divided by -1. So multiplied by 3 divided by -1. So of course -1 will cancel out, 3 and 3 will also cancel out. So I'm going to remain with the gradient of L3, which is actually m2, being given by the following. So it means that m2 will actually be given by -1, and -1 will cancel out. So the gradient will be +3. So remember, this is the gradient. This is the gradient for the line L3. So that is the gradient for the line L3. So I was told that a third line L3 is perpendicular to L2 at the point A. Therefore, if I want to get the equation, I'll use the point A, whose coordinate, we had found the coordinate for point A to be 2, then of course 6. So A has the coordinates of 2, then comma 6. Therefore, I'll use this coordinate with a general point, which I'm calling xy, to find the gradient or to find the equation of L3. Now, if I let this to be my x1, then this to be y1, then of course this to be x2, then this to be y2, then we know that the gradient of any given line must be given by change in y over change in x, which is y2 minus y1, then divided by x2 minus x1. So if I substitute the values, I'm going to get the following. So the gradient of L3 is actually positive 3, which should be equal to my y2 is y, so I'll have y, then of course minus my y1 is positive 6, then of course divided by our x2 is x, so we'll have x, then minus our x1 is actually positive 2. So I'll make these a fraction so that I can easily cross multiply, so that these will multiply with that, then of course 1 will multiply with that. So I'll end up with 3 into bracket x minus 2 being equal to 1 into bracket y minus 6. If I open brackets, I'll get 3x, then of course minus 3 by 2, I'll get positive 6 being equal to 1 times y, I'll get y, then of course minus 1 times negative 6, I'll get negative 6. Then on grouping the like terms together, I'm going to get the following. So I want to take negative 6 towards the left hand side. So I'll end up with 3x, then minus 6. Of course, when negative 6 crosses equal sign, it becomes a positive 6 being equal to y. Therefore, it means that 3x, then of course plus 0 is equals to y. Therefore, it means that the equation will be y is equals to 3x, then of course plus 0, which can just be written as y is equals to 3x. But I was told to give the equation in the form y is equals mx plus c. So the equation will be y is equals to 3x, then of course plus 0. It is exactly in the form y is equals to 3x, that is y is equals to mx plus c, where the gradient is 3, then of course the value of c is 0. So we can just state it as y is equals to 3x. Therefore, this is the equation of the line L3. This is the equation for L3. Then we move to part C of the question, which is stating that another line L4 is parallel to L1 and passes through the point negative 1, 3. Find the x and y intercepts of L4. For us to find the x and y intercepts, we first of all need to have the equation for the line L4. So we are told that L4 is parallel to L1. We know that parallel lines have equal gradients. Therefore, it means that the gradient for the line L4 must be equal to the gradient for the line L2, because parallel lines have equal gradients. So let's find out the gradient for L1. So let me go back to the line L1. Remember, L1 was 2y minus 3x minus 6 is equals to 0. So let me find the gradient of that particular line. It was 2y minus 3x minus 6 is equals to 0. So let me just copy this particular equation here. So L1 had the equation of 2y. So this is 2y, then of course minus 3x, then minus 6 is equals to 0. To find its gradient, I'll convert it to the form y is equals mx plus c. So this is positive 3x, then plus 6. I divide through by 2, by 2, by 2, so that I end up with y being equal to 3 over 2x, then of course plus 6 over 2. I'll get of course a positive 3. So if I compare it to y is equals to mx plus c, it is clearly evident that the gradient for the line L1 is actually 3 over 2. Therefore, I'm also going to say that since L4 is parallel to L1, it follows that the gradient for L4 must be equal to the gradient it must be equal to the gradient of L1, which is actually equal to 3/2. Therefore, having the gradient and the given point, we can easily get the equation for the line L4. Therefore, our equation for L4 will be given by the following. So I'm given a point on L4, that L4 is passing through the point -1, then comma +3. Of course, I'll also pick a general point x, y. Then I'll let this to be my x1, then this to be y1, then this is x2, then of course y2. Then the gradient is 3/2. Therefore, we know that the gradient, which is 3/2, must be given by change in y over change in x, which is y2 minus y1. So this must give us y2 minus y1 over x2, then minus x1. Therefore, 3/2 will be equivalent to my y2 is y, then minus y1 is +3, then divided by my x2 is x, then minus my x1 is actually -1. So this will be 3/2 being equal to y minus 3, then divided by x. Of course, minus will give us a positive. So this will be x plus 1. On cross multiplying, I'll have 3 into x plus 1 being equal to, of course, this will multiply with this, just like a 3 will multiply with that. So I'll have 2 into, of course, y minus 3. If I open bracket, I'll end up with 3x plus 3 being equal to 2y, then of course minus +6. So I want it in the general form, that is in the form y is equals mx plus c. So for me to achieve that, I'm going to group some terms together. So I'll end up with, I'll take -6 towards the left hand side of the equation, so that I'll end up with 3x, then of course plus 3, then -6 will become a +6 when it crosses equal sign, is equals to 2y. So this is 3x, then of course plus 9 is equals to 2y, which can be rearranged as 2y is equals to 3x, then of course plus 9. Then I'll divide through by 2, by 2, so that I end up with y being equal to 3/2x, then of course plus 9/2, plus 9/2. Therefore, this is the equation for the line L4. Y is equals to 3/2x plus 9/2. This is the equation for L4. But remember, the question wanted us to find the intercepts. So we'll start with the x-intercept. We know that at the x-intercept, the coordinate of y must always be equal to 0, because x-intercept is a point where the line will cut the x-axis. Therefore, I'll substitute the equation y is equals to 3/2x, then of course plus 9/2 will become, I'll substitute y being equal to 0. So this will be 0 is equals to 3/2x, then of course plus 9/2. So this can be rewritten as, I'll take this towards the left hand side, so that I'm having -9/2 being equal to 3/2x. Then if I want to get the value of x, I can multiply through with the LCM, of course, which is +2. So if I multiply through with the LCM, so LCM is 2. So multiply by 2, then of course by 2. So 2 and 2 will cancel out. 2 and 2 will also cancel out. So I'll end up with 3x being equal to -9. So positive 3x is equals to -9. Then I'll divide through by 3. I also divide through by 3, so that my value of x will be equal to -9/3. I'll simply get -3. Therefore, this is what we are calling the x-intercept. So this is our x-intercept. Then we'll also find the y-intercept. Remember, this is what we are calling the x-intercept, is actually a -3. Then we'll say at the y-intercept, Remember, y-intercept simply means a point where the line cuts the y-axis. So at that particular point, the value of x is always equal to 0. Therefore, the equation, which was y, is equals to 3 over 2x, then of course plus 9 over 2 will become the following. So when x is 0, I'll have y being equal to 3 over 2 into my x is 0, then of course plus 9 over 2. So this will be y is equals to 0, then of course plus 9 over 2. So that means that our y will be equal to 9 over 2, which simply means that y is equals to 9 divided by 2, I'll get 4.5. Therefore, our y-intercept is 4.5. Therefore, those are the x and the y-intercepts of the line L4. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscribe button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.